How are you doing today?
Good.
Oh, what are we on to today?
Hold on, I'm bringing up my work that I want to do. Alright.
You're accessing this online?
No, I have the textbook.
Oh, okay.
Alright. So we're doing analytic trigonometry.
Okay.
And
So,
alright, the first question is for exercises 1 through 4, solve the triangle, and then the triangle is has a side that measures 3.7 units, I guess, and then adjacent to that side is a 60-degree angle, and then a 45-degree angle.
all right. So we're into solving triangles.
Yeah.
And we know that one angle is 60. The opposite side to that angle is 3.7. And
No. The side that's 3.7 is adjacent, so it's the one above the 60. And then the 45-degree angle is right to the right of the 60.
like that?
Yeah, like that.
Okay. So we're going to use the law of sines. Right?
Yeah.
Okay. What does the law of sines say?
Is it the one that's like yeah, that one, sine A over.
Basically says that as long as you're looking at a triangle, the relationship between the sine of any angle and its opposite side is the same.
Yeah.
Okay, and that's key. So I can say that the sine of 45 degrees divided by its opposite side, 3.7, is a fixed ratio. That is a number. It's not going to change in this triangle. Okay, so if I want side x, then
Yeah.
what's that?
Okay.
Okay, then I can say that that has to be the sine of 60 degrees divided by x.
Yeah.
And this is a number, and this is a number. So solving for x is relatively straightforward. Okay? Now, to solve, when they say solve a triangle, they want you to solve all three angles, all three sides. Well, they've made this relatively simple because they gave us two angles. What's the third angle?
It's 40, no, 50, 55,
75.
75.
If there is one skill that's good to have in both geometry and trig, it's the ability to subtract a number from 180.
Yeah.
Right? You're always doing it. Geometry, the entire semester is about that. And trig, there's quite a bit of that also. So if 60 plus 45 is 105, get good at subtracting any number from 180.
Yeah.
So that makes that angle 75. And now if we call this y, then that sine of 75 over y has to be true also.
Yeah.
So I can easily solve for x because there's only one variable in that equation. And I can easily solve for y because there will only be one variable in this equation. I can, set this to that, and there's only one variable in that equation.
Yeah.
So that's how you apply the law of sines. Okay? Now, there's a few things that can present difficulties that you want to be aware of. These are basically very straightforward. Do you have a calculator in front of you?
Yeah.
Okay, let's figure out what the sine of, well, hold on, let's do the algebra here. So we're saying the sine of 3 point equals the sine of, let's solve for x first. So x equals the sine of 60 times 3.7 divided by the sine of 45. Let's come up with an answer for that.
Okay, so
Make sure you're in degrees.
I am. Right. So
should this number be greater or less than 3.7?
Greater.
Right.
No.
Yeah.
Well, yeah, it's 4.35.
Okay.
Or 5.3. 4.5.
Okay, and that makes sense because you always want the side opposite a 60-degree angle to be greater than the side opposite a 45-degree angle. Okay?
Yeah.
And then if I solve for y, I get,
What do you get?
3.7 times the sine of 75 degrees divided by the sine of 45 degrees. I think. Let's see. Sine of 75 over y is equal to sine of 45, over 3.7. So what number do you get for y?
I'm finding it. 4.9.
And that also makes sense. The biggest side of this triangle should be opposite the biggest angle.
Yeah.
Okay? So, these are all very straightforward. Let's jump forward to a tougher one using the law of sines. By that, I mean whenever you're using the law of sines, you eventually have to encounter the ambiguous case of the law of sines. Have you dealt with that yet?
Yeah.
Let's try one of those. And if you don't have it, I can give you one.
I don't have one in front of me, so.
All right, I think I can make one up. You are given a triangle with those two sides and that angle.
Yeah.
Okay? Now, solve this triangle.
Okay, so you would do sine 45 over 8 equals x, or
Let's label this A, B, C.
yeah, so equals c over 10, sine of c over 10.
Okay? So sine of C equals 10 over 8 times the sine of 45. What's that number?
0.883.
Take the inverse sine of that to get C.
62.1 degrees.
Now, here's the trick. There's all kinds of ways of handling the ambiguous case of the law of sines. I've seen at least 3 different methods taught in 3 different textbooks. By far, the easiest one is this one. When you are solving a triangle and you solve for that second angle, always allow for the supplementary angle also. Oops. In other words, if the sine of C is equal to 0.883, well, C could actually be 2 different angles. It could be 62.1 degrees or it could be 117.9. Right? I mean, by trig.
Yeah.
Because remember, sine is positive in the first and second quadrant. Okay, so when you solve for C here, you always come up with 2 angles. Now, in order to have the ambiguous case, this angle plus the one known angle, 45 degrees, if that is less than 180, the sum of those two, then you do have the ambiguous case of the law of sines. In other words, this angle can be 62.1, if I draw it like that, or it can be 117 if I draw it like that. Notice, this is still 45, this is still 10, and that's still 8. The only difference is that angle right there is 117.9. Angle B in the first case is 72.9. But angle B in the second case is, let's see, 45, and this is 162.9, so that would be 17.1. Both of those triangles satisfy the original conditions of angle side side. Notice that if you remember your geometry, when you have angle side side or side side angle, it doesn't necessarily guarantee a specific unique triangle. It can be 2 different triangles under the right conditions.
Yeah.
Now, one of the books I've read said that, okay, you're going to have the ambiguous case of the law of sines if this one angle you were given is less than 90, and if the sine of this ratio is less than some number. I don't know. It's very complicated, difficult to understand, difficult to memorize. Then I found this other method, which is the one I just showed you. This is by far the best method. Now, if this second angle added to this only other known angle, 45 degrees, if that exceeds 180, then you do not have the ambiguous case of the law of sines, and this would not be, you would just cross it out, and you would only have one triangle where angle C was 62.1 degrees.
Yeah.
That's pretty much the law of sines, the ambiguous case of the law of sines. Okay? And you can see that these two triangles both work. And notice that the sine of 62.1 degrees is exactly the same as the sine of its supplemental angle, 117.9. Same number, same plus or minus sign. So these two triangles don't violate the law of sines. Every law of sines applies here.
Yeah.
Okay. Now, in this particular case, we now have three angles in this triangle, which means we could easily solve for side B using the law of sines and this triangle. And in the second case, we have three angles and two sides, so we could easily solve for side B in this case. And side B is different in each one. Okay? If this supplementary angle would have come out to be 136, well, 136 added to 45 exceeds 180. There's no way you can have a 45 and a 136 degree angle in the same triangle. So I would say cross that out. You do not have the ambiguous case. We only have one triangle.
Yeah.
That's the way to handle the ambiguous case of the law of sines. Now, let's change one thing here. Let's make that 10 and that 8.
That's the same.
No, it's not this. Oh, actually, yeah, you're right. That would also be an ambiguous case. Oh, that's the same. I see what you're saying. I meant to reverse them. Excuse me. Okay. If you have that case, this probably does not work. Let's just verify it. Let me erase this one. Okay. So we would have the sine of 45 divided by 10 has to equal the sine of C divided by 8. So the sine of C is equal to that. Can you give me a number for that?
0.56.
And what does that make C?
34 degrees.
34? So what's the supplementary angle? You always want to figure out the supplementary angle.
The supplementary angle is 146.
Okay. Now, notice that we cannot have a triangle with a 146 degree and a 45 degree angle in it.
Yeah.
So this particular case would not result in the ambiguous. I can cross this result out. It's impossible. And the only possible triangle I can come up with is this one, and whatever this angle is must be 101, And then, of course, you could figure out side B based on the law of sines.
Yeah.
Okay? So that's the way to handle the ambiguous case of the law of sines. And you're only going to get it when you have side-side angle. Do you know what I mean by side-side angle?
Yeah.
Side-side angle. As opposed to side, angle, side.
Yeah.
If you have this case, you actually have to use the law of cosines, and there's no way you're going to have an ambiguous case. Ambiguous merely means there's two possible triangles you can come up with.
Yeah.
Now, before we get into the, have you had the law of cosines yet?
Yeah, a little bit.
Okay, so you've just started that.
Yeah.
Let's talk about one other thing with the law of sines. I'll see if I can think of, and this is critical. Solve this triangle.
Okay, so angle C is 70 degrees, and then it's going to be 10.
Let's go through the process. I made this up in my head because I wanted you to see what happens when I put up an impossible triangle. Notice that you can't have 20 opposite a 40-degree angle and 10 opposite a 70-degree angle.
Yeah.
So I've basically drawn an impossible situation here. I'm going to show you that the law of sines will reveal that. Okay? So let's even ignore that for the moment and see if we can figure out side B using the law of sines.
Okay, so...
In other words, let's say you don't spot the fact that we have an impossible triangle. The law of sines will always point it out for you. So we have the sine of, let's reverse it. You know, you can always do these reciprocals like that. In other words, you can reverse the numerator and denominator as long as you do it consistently.
Yeah.
Okay. And the advantage is that this is going to tell me what B is.
B equals...
without having to cross multiply. It's going to be 10 times the sine of 40 divided by the sine of 70.
It equals 6.84.
Yeah. And this did not show what I was looking to show. Excuse me. Let me get there. There's nothing wrong.
Yeah, I was thinking that because it would just spit out the number that was quoted.
What I needed was, let's see, here's what I need. I need a 70-degree angle opposite a side of 10, and let's make that side 20, and see if we can figure out what angle B is. Okay?
Okay.
So here's our situation. So we've got the sine of B opposite 20 equals the sine of 70 over 10. So now let's solve that. what is the sine of b equal to? What is 20 times sine of 70 over 10?
1.87.
Okay. There's the error.
Yeah, and then it gave me the error.
Sine
And I
cannot
tried to-
be greater than +1 or less than -1. So when you come up with the sine of an angle is greater than 1, it means you have an impossible triangle. There's no way this triangle can exist where I have 10 opposite a 70-degree angle, and I have a side of 20 opposite whatever that angle is. That angle has to be too big. It makes it more than 180 degrees in this triangle. So when you're given an impossible triangle like that, and actually I didn't know for certain that it was impossible even with these 3 dimensions, the law of sines will tell you. Just go through the law of sines, and if you get the sine of an angle is a number greater than 1 or less than -1, you know that it's an impossible triangle.
Yeah.
All right. To me, that is the 2 greatest difficulties in using the law of sines. We just covered the 2 toughest problems you can encounter. Now, you want to do some more law of sines problems to get comfortable with it, or you want to go on to the law of cosines?
No, we're just doing law of sines problems right now.
You have some?
Yeah, I have some more.
Let's go ahead and do them and practice.
Next one is the CB side is 22.
The what side?
Okay, so the A side. A side is 22. C angle is 35. The C angle, not the B angle. And then the A angle is 100.
They always give you 3 pieces of information when they're asking you to solve a triangle.
Yeah.
If they give you a side and an opposite angle, then automatically it's law of sines. That's what you have to use the law of sines, is you have to have that relationship. In other words, if they gave us B, well, now we do not have that relationship. We don't know what, well, we actually do because we could figure out the 3rd angle. Okay, let's continue with this problem here. So let's solve this.
Okay, so it's going to be...
I'll even draw a picture of it.
Well, so the other angle is going to be 45 degrees.
Okay.
And then to find side C, it's going to be sine 100 over 22 equals sine C. Oh wait, no, sine of 35, and then over side C.
Okay.
Yeah.
So let's come up with side C. I'm going to cross multiply and then divide both sides by sine of 100. So what do I get? I get 22 sine of 35 divided by sine of 100. What number is that?
Hold on. 0.126, and then sine inverse. It's 7 degrees, or 7. Yeah, no, 7.
7 sounds like it might be correct. If opposite the 100-degree angle is 22, then opposite the 35-degree angle it could be 7. Okay? Now, let's see. We already have this ratio, so let's use it to figure out B. So we've got the sine of 45 over side B.
So it's going to be 22 sine 45 over 100.
Over sine 100.
Okay.
Notice that the sines are going to be positive no matter what they are. The biggest angle you could ever have would be 179 degrees, and that's in the second quadrant, so it'll be positive. So you're never going to produce a negative number with any of these.
Okay, this is 15.7.
All right, that's believable. It's a little strange.
I think I left off the sign when I divided it by 100, so it would be 12. It's not 7.
That makes more sense.
No, the C side is 12, not. And then it's this.
Okay. All right, that fits better. In other words, 35, the sine of 35 is to 12 as the sine of 45 is to 15. Makes more sense than 7 and 15.
Yeah.
Just from eyeballing it. Okay? So whenever they give you two angles and a side, well, first of all, when they give you two angles, they're giving you three angles, right? So whenever two of the three pieces of information are angles, they're really giving you four pieces of information.
Yeah.
And if they give you nothing but three angles, you can't solve the triangle because that could be a bunch of triangles. That's not a unique triangle.
Yeah.
So the only really hard ones is the ones where they give you only one angle and two sides. Go ahead. Sorry.
All right, the next question is, angle A is 40 degrees. Angle B is 30 degrees. And then side B has a measure of 10.
Okay. What's angle C?
C is 110.
Okay. So we need side A and side B. Side A and side C.
Yeah. Okay, so sine 30 degrees over 10 equals sine 40 over A.
Now, let's just talk about that for a moment. It's not even that important. But which would be easier to come up with a solution here? If I write it like this, or if I write it like this?
The second way?
By quite a bit. In other words, is all I need to do to solve that for A is to multiply both sides by sine 40.
Yeah.
To solve for A up here, I've got to cross multiply and then I got to divide everything by sine 30. So I got to do at least one extra step up here. So since you can put these, you can switch the numerator and the denominator. If I know I'm solving for side A, then I'm going to start my equation with that, putting that in the numerator. And then I'm going to put this in the denominator, And then I'm going to put the only known ratio we have, which is 10 over the sine of 30. Now, A is that. Go ahead and come up with A.
It's 12.8.
Okay. And the last one is side C that we're trying to come up with. So I'm going to do the same logic. I'm going to make sure C is in the numerator, the little side C. Okay. And again, I merely have to multiply both sides by sine of 110. And I have my answer, which is what?
18.7.
So the biggest side is opposite the biggest angle. The next biggest side is opposite the next biggest angle, and the smallest side is opposite the smallest angle. So that passes the ballpark test.
Yeah.
All right. I'm quite certain you know how to do all of them that have two angles and one side. Do you have any that have two sides and one angle?
Yeah.
Let's do one of those.
Here. Angle A has 32 degrees. Is 32 degrees. Side A is 17. And then side B is 11.
All right. Now, this is a triangle. 32 there, 17 there, and 11 there. So, first of all, this could be the ambiguous case. Why? Because it's side, side, angle. Whenever you have side, side, angle, or angle, side, side, you have a possible ambiguous case. So this is the case where you make sure when you solve for that second angle that you solve for both that angle and its supplementary angle. So let's do this.
Okay, so
if I'm solving for side B, or angle B, right?
Yeah.
That's my first step. Then let's put it in the numerator.
Sine B over 11 equals sine 32 over 17.
Okay, multiply both sides by 11. Come up with sine B.
$20.
How much?
20 degrees.
And the supplementary angle
160 degrees.
is the 160 possible.
No.
So we have our triangle. Oops, let's see, excuse me. B was 20. And what's angle C?
It is 128.
And what is side C? Now,
It is.
and how am I going to set it up?
You're going to set it up with the side length and the
Okay, give me the equation.
numerator. So it's going to be 17 or C.
I would start there because I know exactly what I'm doing when I do that. In other words, I know that there's only one thing I'm trying to solve for here, and that's side C. So let's put that in the numerator on the left.
Okay. So C over sine 128 equals 17 over sine 32.
Yeah, and you can use either relationship at that point. I could also have used 11 over sine of 20. They're the same ratios. Okay? So
Yeah.
C equals all of this. What is that number?
Hold on.
Should be a fairly large number, much more than 17. I would guess 30 or 40.
So it's 17 sine 128.
Sine of 128.
Yeah, and then divided by sine 32. And that gives me 25.
All right.
25 before I get to the sine inverse to find. Oh, no, never mind. Yeah, that makes sense.
25 doesn't actually sound right, but you did 17 times the sine of 128 divided by the sine of 32?
Yeah.
Hold on, let me bring up my calculator and do it. Oh man, not as easy to do as I thought. So I got 17 times the sine of 128 divided by the sine of 32. 25.27, which kind of shows you something. It shows you that these aren't linear, these relationships. In other words, this angle is 4 times that angle. Exactly 4 times. And yet this side is only 1.5 times that side.
Yeah.
So don't expect them to be linear. So sometimes the ballpark test, if you make it linear, you're going to get off. In other words, this was not that amazing, the fact that this came out to be 25. I've seen that before where it didn't look right because it didn't look like it was big enough, because the one's tendency is to want to make all these relationships linear. But notice it's not 128 degrees over 25 equaling 32 degrees over 17. It's the sine of that and the sine of that. That's why they're not linear, because after you've taken the sine, it comes up to be a whole different number. All right, so that was a good problem. We were able to show that it was not ambiguous and that it produced a unique triangle, and we came up with all 3 sides.
Yeah. All right.
Got another one with 2
Yeah.
sides and 1 angle?
Yeah. Angle A equals 70 degrees. Side B, oh no, angle B is 70 degrees. Okay. And then side B is 14. And then side C is 9.
Okay. Now, first of all, in order for this also is a possible ambiguous case. When you do not have to consider the ambiguous case is when the only angle they give you is greater than 90. If this is 90 degrees, it's impossible for it to be an ambiguous case.
Yeah.
Okay, so it's only when it's less than 90 that we even have to consider it. But again, we have side, side, angle.
Yeah.
We don't have this case where you would have 9, 14, and 70. That would be side, angle, side. Side, angle, side, if you remember from your geometry, produces a unique triangle. not an ambiguous triangle. So for it to be ambiguous, it's got to be side-side angle, which this is. So let's try to solve this. So what's the first thing we're going to try to solve for?
Side angle C.
Okay. So how should I write my equation?
C over, oh no, sine C over 9 equals sine 70 over 14.
Okay. So sine C equals that. What number is that? Sorry, that's my phone whistling at me.
37 degrees.
What's the supplementary angle?
It is 143.
Is that a possible angle?
No.
And you'll find the closer this angle is to 90, the less likely it is to be ambiguous. So
Yeah.
you have your ambiguous cases when this is a smaller angle, usually. Okay, so hold on a second. We didn't do this right. Unless you left out a step. What's sine C equal to?
Sine C is equal to 0.6.
And then what's C equal to?
37.
Okay, you did do it right. You just left out that one step.
Yeah, I did the inverse sine.
Yeah, I just didn't hear you do that. Okay. So
Yeah.
our triangle is now pretty much decided. We've got angle C is 37 degrees for sure. Angle B is, angle A is what?
Angle A is 60. No. Yeah, 73.
73. What's the only thing we need?
Side A.
Okay, so what's the equation?
A over sine 73 equals 14 over sine 70.
So A is equal to that. What number is that? Should be about 15.
Yeah, it's 14.2.
14 point what?
2.
I knew it had to be slightly bigger than side B because 73 degrees is slightly bigger than 70.
Yeah.
All right. Now, I think we've exhausted the law of sines in terms of your learning, and I think you understand it perfectly now.
Yeah.
Where it falls down is when you have two sides and an angle. Well, now you don't have that relationship. In other words, how do I proceed in this case? I've got angle A, but I don't have side A. And I have sides B and C, but I don't have angles B and C.
You have to use cosine.
This is where you have to use the law of cosines.
Yeah.
The law of cosines says side A is equal, squared. It's kind of similar to the Pythagorean theorem. Starts out exactly the same, like that. But then you have to subtract 2b times c times the cosine of this angle A. And there are three laws of cosines. In other words, that's just one of them if you're solving for A. If you're solving for a different side, then it's the other two sides, minus 2AC, but now it's the cosine of B. And if you're solving, go ahead.
We just barely touched on this at the end of the class.
Okay, that's okay. And then the third one would be what?
B squared plus A squared minus 2 AB times cosine C.
Yes, the biggest problem is memorizing it. But notice you only have to memorize one of them. If you memorize one of them, you see the pattern, and you can figure out the other two.
Yeah.
So it doesn't really matter what you're solving for, which side or which angle. Now, where do you use the law of cosines? You use it in this situation, and you use it in only one other situation, where you have three sides. That's it. Notice that in both of these situations, I do not have the sine of an angle and its opposite side in any case. So I cannot use the law of sines. You still end up using the law of sines to solve this triangle, but you don't begin it with the law of sines. You begin it with the law of cosines. You finish it with the law of sines. You end up using the law of sines in all triangles that you solve. But some of them have to be begun with the law of cosines. Notice that if I use the law of cosines here, I can solve for it. Because, well, I'm solving for A, right? I know what B is, I know what C is, I know what those two are, and I know what the cosine of A is. So I'm going to be able to come up with a number for A. Once I come up with that, now I'm into the law of sines to finish the problem. In other words, as soon as you come up with the relationship, the sine of one angle versus its opposite side, you always finish the rest of the solution using the law of sines.
Yeah.
That's pretty much it. The law of cosines is actually easier in the sense that you have no ambiguity, and you don't ever, I believe, you never come up with an impossible triangle. Possibly, maybe you do. Yeah, I suppose you do. In other words, if I made that side 30, that's an impossible triangle. Yeah. Because remember that any side of a triangle has to be less than the sum of its other two sides. 30 is not less than 13, so this triangle can't exist. And so if I gave you this triangle and solved it, well, your first step would be calculating the cosine of one of these angles, and you'd get a number greater than 1 or less than minus 1. So that would tell you immediately that you have an impossible triangle.
Yeah.
And I suppose you could have an impossible triangle here also, if I put a number of 120 down there. That's not going to be a possible triangle either. So the law of cosines can also tell you impossible triangles, but you don't have to worry about ambiguous triangles. When you use the law of cosines, you're only going to get one triangle.
Yeah.
Okay. What else? We got about 5 minutes. You got another problem you want to do?
I guess we can do one more.
Okay. Let's make sure we do one that has one angle and two sides.
Yeah, angle A is 49 degrees. Side A is 32, and then side B is 28.
Okay. So the first thing we need to solve for is
solve for angle B.
okay.
So it'll be sine B over 28 equals sine 49 over 32.
Okay, what's that number? And what's the number for sine B before you take the inverse of it? I mean, I don't know. I guess you can go straight to angle B as long as you understand that that's what you're doing.
It's 0.6.
Okay, and then what's
sine
angle B equal to?
41.
What's the supplementary angle, because this is a possible ambiguous case?
The supplementary angle is 139.
Okay. Is that a possible angle?
No.
We got our triangle. We got angle B. What's next?
Find the angle C.
Okay, what's
So
angle
it'll
C?
be 100. No. 90.
Okay. What's next?
Find the side side C.
Side C. Okay. So the equation?
Sine 90. Oh no. C over sine 90 equals 32 over sine 49.
Okay. Sine of 90 is 1. So side C is that.
It's 42.
That's the biggest side. Makes sense. It's a right triangle. So 32 squared plus 28 squared should be equal to 42 squared, which seems a little odd,
Yeah.
but I'm sure that that's probably true. We don't need to prove that. Yeah, so be a little careful with your ballparks. They can seem odd because, like I said, they're not linear relationships.
Yeah.
In this business of putting the unknown in the numerator, don't worry about that. To be honest, that's just something I came up with today for the first time, is to identify what you're trying to solve for and immediately put it in the numerator makes it the easiest arithmetic.
Yeah. And that definitely helps.
Yeah, it should help a little bit. Keeps you from having to cross multiply and then divide, which is a lot more math, actually.
Yeah.
All right. Lucas, I will let you go, and I will talk to you next Wednesday.
All right.
Have a good week.
Yeah.
Bye-bye.